Hello everyone. Here we have a problem. It is a moment problem where we have three pivots P, Q, and R. We have upward forces R1, 99 newtons R2, and we have downward forces 45, 72, 90, and 54. The question asks us to find the reaction R1 and R2. We can solve this problem by taking moments from any of the pivots P, Q, or R, or at any point. We can take it here, 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 here. It doesn't matter. So for today's lesson, I want to take moments at pivot Q. Okay, and that is how I will solve this question. All right. So if I take moments at pivot Q, this is a downward force, so we'll have 90 Newton will be clockwise, the 54 Newton also towards pivot Q, it will be clockwise. Okay, R2 is an upward force, it will be anti-clockwise. Okay, so 72 Newton will be anti-clockwise, the 45 Newton will be anti-clockwise. Okay, the R1 will be clockwise. So the first thing is you should be able to identify clockwise and anti-clockwise moments. Okay, because I am taking moments from pivot Q, the 99 Newton it does not have any perpendicular distance defined by it directly from Q, so it means that will be 0, so the moment will be 0. Okay, now from the principles of coplanar forces, it says total upward forces is equals to total downward forces. So the upward forces are R1, 99, R2. This equals to downward forces are 45, 72, 90, and 54. So R1 plus R2 plus 99 is equal to, if I should add 45 plus 72 plus 90 plus 54, I'll have 261 newtons. So I can say R1 plus R2 is equal to, if I should collect like terms, it will be 261 minus 99. R1 plus R2 is equals to 162 Newton. I can call this equation 1. Okay. Again, from the principles of coplanar forces, you see at equilibrium, total clockwise moments must be equal to anti-clockwise moment. So we are taking moments at pivot Q. So it is important you state that, okay, where are you taking moments from. All right, so what are the clockwise moments? Let's start with that. For the 90 Newton, the perpendicular distance directly from pivot Q is just 0.4 meters. Okay, so the moment, which is the product of force and perpendicular distance, that will be 90 multiplied by 0.4. Then I will continue. What is the other clockwise moment, or the clockwise force? 54 Newton is acting clockwise, but what is the perpendicular distance from pivot Q? That's 0.4, 0.2, 0.3. Okay, so that will be 54 into 0.4 plus 0.2 plus 0.3. Okay, do I have another clockwise moment? Yes. R1 is also going to act clockwise. R1 is acting clockwise, and the perpendicular distance from pivot Q is just 0.1 plus 0.2. So that will be R1 into 0.1 plus 0.2. Okay, so we said this must be equal to the anti-clockwise moments. Okay, so what are the anti-clockwise moments? We have R2 acting anti-clockwise, and the perpendicular distance is 0.4 and 0.2, okay, from pivot Q. So we can say R2 into 0.4 plus 0.2 plus, let's go for the other anti-clockwise moment. We have the 72 Newton, and the perpendicular distance is just 0.2 meters. Okay, so that will be 72 multiplied by 0.2. Okay, and the other anti-clockwise moment is the 45 newtons acting at a distance of 0.2, 0.1, 0.5. So we can say 0.5, 0.1, 0.2. Okay, 0.5, 1, 0.2. 45 newtons zero 0.5 plus 0.4 plus 0.2. Let me just analyze that quickly. 0.5, 0.1, 0.2. 0.5, 0.1, 0.1 plus 0.2. Okay, I think we have done everything, right? Yes. Okay, so let's simplify. 90 multiplied by 0.4, that is 36, plus 54, if you should multiply it by 0.4 plus 0.2 plus 0.3, you have 48.6, plus 0.1 plus 0.2 is 0.3, so we'll have 0.3 R1. This is equal to 0.2 plus 0.4, that will give you 0.6, so we'll have 0.6 R2. 72 multiplied by 0.2, that will be 14.4, plus, if say 45 multiplied by 0.5 plus 0.1 plus 0.2, that will give 36. Okay, I have 36 on both sides. 36 can cancel 36. If I want to just make it a bit more simpler for myself, so I'll have 48.6 plus 0.3 R1 is equals to 0.6 R2 plus 14.4. Okay, so collecting like terms, I can say 48.6 minus 14.4 is equals to 0.6 R2 minus 0.3 R1. 48.6 minus 14.4, that is 34.2, is equals to 0.6 R2 minus 0.3 R1. Okay, so what I can do is I can call this equation equation 2. So if I go back to equation 1, which says R1 plus R2 equals to 126, so then I can make one of them the subject of the formula. Let's say R1 or let's say R2, it doesn't matter. So which means R2 will be 162 minus R1. So wherever I have R2, I can substitute 162 minus R1, okay, in the equation 2. So coming back to this point, 34.2 is equals to 0.6. What is R2? R2 is 162 minus R1. Okay, that is 162 minus R1, then minus 0.3 R1. Simplifying this, I'll have 34.2 is equals to 0.6 multiplied by 162. That will be 97.2 minus 0.6 R1 minus 0.3 R1. So that will be 34.2 is equals to 97.2 minus, okay, that will be minus 0.6 minus 0.3, that will be minus 0.9, minus 0.9 R1. So if I should collect like terms, I will have 34.2 minus 97.2 is equals to 0.9 R1. Okay, so we'll have minus 63 is equals to minus 0.9 R1. So if I divide both sides by minus 0.9, both sides by minus 0.9, what do I have? I will have R1 as 63 divided by 0.9. R1 will be 70 newtons. So because I said R2 is equals to 162 minus R1, substituting that will be 162 minus 70, then R2 will be 92 newtons. Okay, that is it. Thank you very much.